This chapter is about computer network. What is a computer network? It is a collection of computers and devices, or end devices, that they are connected together by network devices. Why? To transmit data through the cable or through the transmission media. This is controlled by the protocols, the network protocols. Network can be different in size. It can be small as 2 computers, or it can be most complex with thousands of computers. The biggest network in the world is Internet. It's made of billions of computers connected and other devices connected across the world. The computer network can connect computers, printers, scanners, and they use switches, network cards, routers, and the media is wired or wireless, and the most protocol that is used is TCP/IP. Okay. The network components or the network infrastructure has 3 categories of components, of hardware components. We are talking about the hardware here. All right, so we have end devices, intermediate devices, and network media. We'll talk about each one. End devices, these are the devices that form the interface between the user and the underlying communication network. Because you don't communicate with the router directly. You don't sit on the router or switch and start communicating, right? You have to go through your laptop, through computer, scanner, all right? So these are called end devices or hosts. The hosts send and receive user traffic. Some examples of end devices: computers, printers, telephones, security cameras, mobile devices, tablets. We have also an important part for your network card, for your network, and as a good example for connecting your end device, or an important component is called NIC, or Network Interface Card, such as the one here in the picture here. Okay. It is a communication device that enables a computer or device to have a networking capability to access the network. So you connect your end device to the network through the NIC. This network card coordinates the transmission and receipt of data, instructions, and information to and from the computer, okay, or the device that's containing the network card. Could be a printer, network printer. Now we talk about the intermediate device networks or intermediate devices. We will stop at slide 11 or 12, just like the men's campus, okay? So we'll not continue further. Intermediate devices or network devices, they interconnect in their end devices. These devices provide connectivity and work behind the scenes to ensure that data flows across the network. Okay, so they connect individual hosts to the network, and they can connect multiple individual networks to form an internetwork. Okay? Do you understand this meaning? So it can connect multiple LANs. like the router, can connect multiple LANs. The switch connects the computers within one LAN. If I have different LANs, I want to connect them together, I need a router. So example of these intermediate devices: wireless router, multi-layer switch, LAN switch, router, firewall appliance. Let's talk about some of these network devices. A switch. A switch connects devices or connect computers to a network. Okay, it forwards data frames over the network to the corresponding device. So for switch, it uses frames. You have to remember this. And it forwards messages to a computer in the LAN, in the local network. Okay. The switch has multiple ports. We will show you this in the lab, inshallah. Router, on the other hand, it manages traffic between two or more networks. And it also helps to find the best route or path for the packet. So router deals with packets. Remember this. We have also wireless access point. It allows a Wi-Fi compliant device to connect to a wired network. This is a diagram here. So it's very obvious here. We have a switch connecting local network computers or end devices. Then we have two networks connected with a router. Network media can be cable or can be wireless. It is transmission media or communication links that is the medium through which the data is transferred. It can be physical or wired, or it can be wireless. So these are the two types: wireless and wired. If it's a LAN media, it is a solid line when we do your packet tracer exercise, inshallah. If it is a WAN link, then it's given this link, this red line. You see this line? This is a WAN link. When you describe your network topology, we have two types to describe your network topology. We have a physical topology, which is this one here on the left side. It's called physical because it refers to the network's hardware and how computers, other devices, and cables or radio signals work together to form the physical network. And you can see here we have the building name, the floor number, things like that. More about physical location, physical communication, how they are connected. The other one is called logical. It is about how software control access to the network resources. Okay, so you will have IP addresses, okay, and how users and software initially gain access to the network, and how application access are shared also. So this is all called logical topology. See the IP addresses, very obvious. We don't care how they are physically located, but we care how they are logically connected. Peer-to-peer network. Peer-to-peer meaning same power. Peer-to-peer network, in small networks, we can have very small network. Instead of me buying a server to be dedicated for my network, each computer can access as a client or server. And if I have a computer, this computer has a file I want to share with another user. I don't need to go and buy a server and install. It's very expensive and not efficient. I can share it through peer-to-peer network, all right? Or if I have a printer connected to my computer at home and someone else wants to print, do they need to go and buy another printer? No, you can share the printer so that they can print through your computer. Have you done this before? Yeah, many times. So this is called peer-to-peer network. Okay. So the operating system of each computer on the network is responsible for controlling access to its resources without centralized control. The computers called hosts on the network form a logical group of computers and users that share resources. Each computer on a peer-to-peer network controls its own administration resources and security. For example of these operating systems we have, for peer-to-peer, we have Windows, Linux, Mac OS. We have also iOS and Android for mobile devices. The advantages and disadvantages of peer-to-peer network are here in slide number 11. By the way, slide 12 is repeated, so you can ignore it. So the advantages of peer-to-peer is they are simple. You can just share the resource. So even if someone who's not expert in networking can share their file or printer. They are less expensive often. They are often less expensive. Okay? Because you don't need to buy a more expensive operating system like Windows Server 2019. An example of a desktop operating system is Windows 10. I think most of you use Windows 10. The disadvantages, on the other hand, they are only meant to small, very small networks. They are not scalable. You cannot use it for big network. Also, they are not necessarily secure because they don't have the advanced security options. Okay. So they can be easily discovered and maybe used by unauthorized people. Also, they are not practical for connecting more than a few computers because then it will be too much time consuming to manage these resources. So it's better to centralize the resources if you are having a big network for efficiency.